Well, bring out the GIMP.
Think the GIMP's sleeping?
Well, guess you'll just have to go wake him up now, won't you?
GIMP is a bit underrated and horribly underfunded. Crit is there for drawing, GIMP is not great for that. Inkscape's there for vector work, GIMP isn't exactly amazing at text, but it's right fucking decent at your bog standard bread and butter raster image editing. A year ago GIMP 3.0 dropped, and now this thing even has non-destructive editing.
I guess you could say things are getting pretty serious.
Photoshop can do more, but I don't know how to use Photoshop. I only know about how much better it is from the rumors at the quarterly earnings reports. We even had GIMP on our school computers. I've been using this thing since I was like 12.
I'm gonna call Child Protective Services!
The whole Adobe suite also doesn't really run on Linux. I think the only Adobe product that ever ran on Linux was Flash, which ran terribly and is long since dead. Long live the Flash era, but I'm glad that technology died a fiery death.
I guess I'd start with Flash.
Sometimes when we get rid of things like the floppy disk drive on the original iMac, people call us crazy.
Or at least premature, maybe.
No, they call us crazy.
Oh, okay.
And Flash looks like a technology that had its day, but is waning. And HTML5 looks like the technology that's really on the ascendancy.
I can't believe I'm saying this, but thank you, Steve Jobs. And I'm not dealing with emulation layers. There's only a small portion of truly essential software applications I bother with that for. And I'm definitely not dual booting for creative work, so I'm stuck here with this guy. Bottom line, if your needs are simple, and I know for 90% of you out there, my fellow impassioned graphic designers, your needs are simple, then GIMP is pretty great. If you need just a little bit more than basic features, then it's still pretty good if you get through the pain of learning its UI. This magazine cover was made in GIMP, and does this even qualify as foreshadowing? It's been staring at you from the background this entire time. Go to Filters, Render, Sinus, and you'll find this ugly, horrible mess. I have no idea why they made these the default settings, because it's possible for this effect to not be a complete eyesore. When I was putting together a little marketing site, I wanted to have a moving version of the pattern, like the one you've been seeing. So I was gonna have to figure out how this effect even works. And obviously it's just a bunch of sine waves combined and mapped onto 2 dimensions. I could get something that looks close enough by just messing around for a bit, but I wanted to have the exact same one. If we're using Photoshop, we'd have to go off reverse engineering, but this is GIMP, this is free software. The code is right over there. We can just go and read it. So first we'll go clone the repository, and some of you guys wanted the László Tóth video, but no, you're getting a deep dive into GIMP source code. Yeah, this is taking a while. Actually, while we wait, let's just do the László Tóth video. I have an ongoing fascination with Wikipedia articles for people who are known for just that one weird thing they did, but Wikipedia keeps removing those. The László article is now just the article about what the guy is known for, which is vandalizing Michelangelo's Pieta statue. Quirky. So this incredibly handsome Hungarian man, he moves to Rome, he sends a bunch of letters to the Pope about him actually being the second coming of Christ. Then, when he gets left undelivered, he proceeds to grab a hammer and smash the shit out of the Pieta during Easter while shouting, "I am Jesus Christ." Writer and comedian Don Novello, which is an amazing name for a writer, started writing these deranged satirical letters to famous people, signing them László Tóth. He even published a lot of these with the responses in 3 volumes: the László letters, Citizen László, From Bush to Bush, the László Tóth letters. I mean, that's one way to immortalize yourself in the annals of history, which is just gonna be Wikipedia eventually. Look, Wikipedia even has a whole list of people who claim to be the Messiah, like this guy. You know, I released my first video on Jesus' birthday, then I got banned, and I got my account back around Easter, so maybe I'm Jesus. Really makes you think. You better put me on that list. You're on a list, but it's not the FBI watch list, it's a list of Messiah claimants on Wikipedia, like top 5 Family Guy moments. Why does Wikipedia have such an obsession with lists, and why do I have such an obsession with Wikipedia's lists? List of common misconceptions, list of major crimes in France, list of major crimes in France before 1900, list of shopping malls in Jordan, list of cannabis-related lists.
Happy Super 420.
Category, lists of lists. So I started grepping, and I can't find it. There's one here, but this doesn't take me anywhere. There's also a reference in sanity.c, which is really fitting. These keep referring to a thing called Gegel, again with the naming, which is apparently this thing. So the sinus code isn't in the main GIMP repository, it's actually in the library. So we'll go grab that again. So not much is known about László Tóth after he famously knocked the nose off the Pieta. He's from Hungary, but apparently the Italians deported him to Australia, which is fair, to be honest.
Gentlemen, this is Democracy Manifest.
Found this inquiry sent in by Danny Bloom to The Guardian, claiming to be an old friend of László. László, if he's still alive, it must be around 70. Has anyone seen him? Apparently, it kept the whole Messiah thing on the down low, just between him and the Pope, which explains why he had friends. He did have a habit of always carrying a Bible around with him, which he'd often be reading, which is eccentric but not concerning. And based on the age estimate, the inquiry was probably published around 2009. We can surmise Danny must have had a lot of time off during the
unprecedented financial crisis.
Then there's a bunch of conflicting hearsay from various other people reporting László's sightings. The last I heard, he was living in Sydney. And no, he's not me. I was born in 1972 and I only met him once, by Les Tóth in Sydney, Australia. Overall, all I can find is the opposite of information, and it's become difficult to Google him after the release of The Brutalist. Our Vandal shares a name with the main character, but from what I can gather, he lived a quiet life somewhere out in New South Wales until he possibly died in 2012. But there's a lot of László Tóths out there, so we don't really know. I swear online research used to be way easier. Now it's just a bunch of regurgitated SEO crap that floats to the top of Google search results, just poorly written, poorly researched, probably even research by reading other regurgitated SEO crap, just garbage in and garbage out. It's been SEO, typewriter monkey model collapse way before ChatGPT was even a...
And you, sir, are you waiting to receive my limp penis? Ah, yes.
And this time I actually found it, the magic sauce, to produce this saucy looking thing. So how's it work? We got prepare coefficients, which sets up parameters in this here data structure, which we're gonna have to figure out. This looks suspiciously like a matrix. Then we got blend, which blends linearly, bilinearly, cosine, doesn't matter. Then color is the base color, and decolor is the change in color. And that's pretty much all there is to it. The meat is over here, in the filter processing function. If you're a developer and you're confused about the indentation style here, you're using the GNU C style. You got K&R style on the right, you got corporate Java Hellscape style, sometimes also called Allman style, on the left, and you've got GNU style, which, I mean, the Linux kernel coding style document says the following about it. Coding style is very personal, but at least consider the points made here. First off, I'd suggest printing out a copy of the GNU coding standards, not reading them, but burning them instead as a symbolic gesture. For the actual substance of the code, we're going to have to get into some math. And I'm not a huge math head, I'm more of a math user, maybe a math enjoyer, perchance.
Perchance. You can't just say perchance.
But I don't do a lot of math just for math's sake. The only reason I've retained any math knowledge at all is for computer graphics and game physics. So what I'm trying to say is if you're living with mathematical anxiety, this is going to be some pretty simple and straightforward maths. You're probably used to seeing sine waves plotted like this. More generally, you're used to seeing f of x equals something, where f of x is defining some sort of curve, and that's clearly useful. Shout out to René Descartes. But schools typically stop at showing you how to relate mathematical functions to lines and curves only. But we don't want to do useful things. We want to do fun things. And we can do far more visually interesting things with this Cartesian system if instead of just saying y equals f of x, we say that g equals f of x and y. G here is standing for gray, so g equals 0 means that we color that point black, and g equals 1 means that we color it white. As an example, this is what that would look like for this arbitrary function. We can break more boring high school math textbook conventions by looking at time. You'd usually see time progressing linearly on the horizontal axis in graphs, but we're not limited to static images on paper, so why don't we just add time to our formula? Here the time axis is represented in real time as you're watching the image change. We can get colors by calculating red, green, and blue values individually, or we could also just say that c equals f of x and y, where c, the color, is a vector of RGB values, which is how we usually do this in computer graphics. Getting back to the code, we have an outer loop counting j towards pixel height and I towards pixel width. We then get our x and y values by dividing over the image dimension, normalizing the pixel values over the 0 to 1 range. So this over here, this is our boring scaffolding, our plotting machine. This inner bit, that's what we're interested in. That's where we find the secret formula for GIMP's special homemade sauce. We first just store this intermediate result, and we have our first sign. Very exciting. Then the code does this, and this pattern here repeats a lot, so we can get it looking a lot cleaner by extracting that into FFI. And that is pretty much how the cookies learns. We got 1, 2, 3 sine waves combined in some sort of way, just like we expected. Then finally, to get the color, the code does this whole thing. 1 plus our G factor from above over 2 multiplied by complexity, then we blend and raise it to some power. So what's the importance of blend? We're looking to get some color that's somewhere between color A and color B, so we want color plus a factor times the delta color. And obviously then we want that factor to lie between 0 and 1, so that at one extreme end we get entirely color A, and at the other entirely color B. These blend functions ensure that their output lies on the 0 to 1 range. Then raising it to a power biases it towards either end, power 1 being neutral, 1.5 leading color A, 0.5 leading color B. So we multiply A and add, and we get a color value. Now we want to see some movement, but this is what that would look like if we use the C code directly, which is going to be a problem if we want to get some real-time pro gamer frame rates on a website. There's not a whole lot to be optimized here since it's just doing the math on the CPU, but my computer also comes with this 4096 barrel pixel shotgun, so we're going to make this run fast by making use of our gamer processing unit. Since we're deploying it to the web, we'll be using OpenGL or WebGL, and this is what that math looks like as an OpenGL shader. The CX, BC, CF, and DC values here are our uniforms. We call them uniforms because for every pixel they'll have a uniform value. Think of this like aiming your pixel shotgun. All the barrels are moving in unison, but they're all slightly spaced apart. The coefficient matrices are generated like this. Then I'm going to animate this using a state machine that generates random new states and interpolates between them. For all that work, we finally got this to show for it. We could call it quits here, but I got curious about this coefficient matrix because in the GIMP UI, you're only able to provide a random seed in order to generate the matrix, but that's not a whole lot of control. You're just clicking new seed over and over again until you get something you like. If you get something you almost like, you're just going to have to save the seed for later, try again, hoping you get something that looks a bit closer until you give up. A lazy way to represent this would be to have 3x3 sliders, but there's a more interesting way to do it. We can take each of the column vectors of the matrix, and we can treat their two first values as x and y Cartesian coordinates. That allows us to use an input method that's very common in VSTs, where we move some dots around, and something happens. Now what I have so far is some Rust code deployed to the web as WebAssembly, so I'll just build the UI in JavaScript and layer that on top of the WebGL canvas. I don't mind JavaScript, especially for prototyping, and especially for prototyping user interfaces, but I hate that ecosystem with an undying passion. If bridges were engineered the way front-end tooling is, we'd be court-martialed. So if I can avoid ever seeing an NPM or Webpack error message ever again, I would rather build my own shitty version of React from scratch.
Which I am quite excited to do. I was thinking to myself last night.
There we go. We can fine-tune the pattern, mostly except for that third parameter, which, if we think back on how these values are used, the z values of the column vectors control the phases of the sine waves, which means that it's an angle. It goes from 0 to 2 pi. So we can represent this as each of our little x, y, and z dots having a direction. Just gotta write some code to do that, and now our little dots aren't aimless anymore. I still am, but hey, you can twirl them around. It's fun. They kind of cause the pattern to shimmer, which means that it's a good animation to just play in between the different states. Digital copies of the zine are going for €5 at Gumroad, if you're interested in that, and I have a Blue Sky that you can go follow if you would like updates on what I'm doing, or this. It's mostly stuff like this.
You must exorcise any evil proprietary.
I just shit in my pants. Yeah, boy.
Hey, what's up, guys? It's your boy, Gimpinator, coming at you today with another GIMP tutorial. So we're just gonna start the way we usually do. We're just gonna fire up a new document here. You can pretty much choose whichever one of these you like. I'm just gonna choose toilet paper. And then once you got your toilet paper, you're gonna go to filters, render, and you're gonna choose the sinus. It's really cool. You can just you just put the slider up here and change this thing, and then once you have that down, we're gonna add some bell peppers to this, and we get like a really nice little pattern going, and there we go, and then we're just gonna choose blur, and we're gonna go focus blur, and we're gonna focus on one of these, and we're gonna do it like that, and there we have bell pepper toilet paper pattern. So thanks for watching, guys. Like and subscribe.